Think about it. It's a Black Friday and an online store is flooded with customers. Orders are coming in fast and everything is going great. But suddenly the website slows down. Within minutes, it crashes. People leave and sales stop. What went wrong? The application and its architecture wasn't built to handle such a rush. Now imagine if there is a way to prevent this, something that helps design strong, reliable, and cost-efficient cloud systems. That's where the AWS Well-Architected Framework comes in. Hello everyone and welcome back to ImTechnos. Today we will break down the AWS Well-Architected Framework, a guide to building better cloud applications. So what is AWS Well-Architected Framework? The AWS Well-Architected Framework is a guide that helps businesses build better cloud systems. It provides best practices to make sure applications are reliable, secure, and cost-effective. AWS created this framework after working with many businesses to solve common cloud problems. It helps companies check their systems, fix issues, and improve performance. At its core, the AWS Well-Architected Framework is built on 6 general design principles and 6 key pillars that help organizations create scalable, efficient, and secure cloud applications. This video will focus us on general design principles, while the 6 key pillars will be covered in future videos. Let's start with the first one. Start guessing your capacity needs. In the past, companies had to predict how much computing power they would need. If they guessed too high, they wasted money on unused resources. If they guessed too low, their systems crashed under heavy load. With cloud computing, you don't need to guess. AWS allows you to scale your resources up or down automatically based on demand. This ensures that you always have enough capacity to handle traffic spikes while avoiding unnecessary cost. And by leveraging cloud scalability, businesses can focus on growth without worrying about infrastructure limitations. Now let's explore the next design principle, which is test systems at production scale. Many businesses test their applications in small, controlled environments, but when real users start using the system, unexpected problems arise. Why? Because the test environment doesn't match the real-world production setup. On the other hand, AWS enables businesses to test their systems at production scale, meaning they can simulate real-world traffic and workloads before launching. This ensures that the applications perform well under actual conditions and helps identify potential failures before they impact users. And then we have automate with architectural experimentation in mind. In traditional IT world, making changes to a system was slow and risky. Businesses hesitated to experiment because failures could be costly and difficult to fix. But with AWS, automation and experimentation go hand in hand. AWS provides tools that allow businesses to automate deployments, test different architectures, and experiment with new features, all without disrupting existing systems. Next, we have consider evolutionary architectures. Technology is constantly evolving, and businesses need architectures that can adapt and grow over time. In traditional IT setups, updating architecture often requires costly upgrades and cause disruptions. However, in the cloud, AWS enables evolutionary architectures by offering loosely coupled services, microservices, and serverless computing. And then we have drive architectures using data. In today's world, data is at core of making informed decisions. Traditional IT environments often rely on static configurations and manual adjustments, leading to inefficiencies and missed opportunities. With AWS, businesses can use real-time data and analytics to optimize their cloud architecture. For example, AWS provided services like AWS CloudWatch, X-Ray, Trust Advisor, and AWS Compute Optimizer, which monitor performance, detect issues, and recommend optimizations. And these services feed into a centralized decision-making system, which analyzes insights and triggers automated actions such as scaling resources, performance optimization, and security enhancements. And next design principle is improve through game days. Failures happen. The real question is, how well are you prepared to handle them? In IT environments, teams often react to failures only after they occur. This can lead to downtime, lost revenue, and frustrated users. Since there is no safe way to test real-world failure scenarios, businesses rely on assumptions instead of actual preparedness. In contrast, AWS encourages organizations to prepare through game days. These are controlled simulations where teams intentionally inject failures into their systems before an actual crisis occurs. With AWS services like AWS Fault Injection Simulator, businesses can test their system resilience in a safe, repeatable manner. They can simulate server failures, network outages, or even sudden traffic spikes without impacting the real users. So, as we have seen, the AWS Well-Architected Framework General Design Principles provides a powerful foundation for building scalable, reliable, and efficient cloud system. In upcoming videos, we will dive into 6 key pillars of well-architected framework, where each pillar focuses on a critical area of cloud design like security, reliability, cost optimization, and more. That's it for today. If you have any questions, feel free to drop them in the comments below. Thank you for watching, and I'll see you in the next video. Take care and happy learning.